All right, so, I started off by trying to use my computer. That's always a mistake. Adding technical difficulty, I love doing that. It makes things go much smoother for me, right? So I'm Dave Michelson. I'm with UNC Asheville's NEMAC. If you're not familiar with us, we're an applied research group at UNC Asheville. We do all kinds of fun stuff. I was actually supposed to do this with another coworker, but he couldn't come. So I will make some stuff up in place of him. So here's one thing we say at NEMAC, right? We say we're helping people understand and reach decisions in a complex and changing world, right? But I want you to notice something about this, what it doesn't say, right? It doesn't say that we helping people manage servers in a complex and changing world, right? And there's a real specific reason for that. Because at NEMAC, part of the value that we deliver to customers is we build tools, we help them do data analysis, and if we have to manage servers and become sysadmins, that takes away from delivering that value. And sometimes it can take a lot. So it's been, and I'll add another thing to that, I really despise being a sysadmin. So anytime I can get rid of that task, that's a good thing. Right, and I think a lot of people feel that way. It's, doing patches and anything like that, that's not fun work. Right, so we have a problem, right? And we have two problems, because we have a problem that our customers, right, they don't want to have to pay for maintenance of things that we build, right? Because that can cost a lot of money. For servers to run 24/7 costs money. For us to come on to the server and do any kind of work with it, that costs money too, right? Because at NEMAC, we have to be billable, right? So the problem here is we have to pass that cost to the customer. So now every year they have to pay maintenance on anything we build. And that's probably similar to anybody else. Even if you work at a city or county, you're running into the same problem. You're creating some kind of technical debt by having to deal with a server. So let's try to eliminate servers, right? So how do you do that? I mean, we're not really eliminating servers, but we're eliminating us having to deal with them, and we're putting it to somebody else. So in a sense, we're hiring somebody to do all that sysadmin work that's really not all that fun. So we'll look at this quick case study here. We did some work with the National Fish and Wildlife Foundation, and this was like a test of, for us, this is the applied research part of work that we do, is how can we build like a tool that we would build on the web that needs some pretty complex, what I would call back-end work that you would typically use a server for, so that this front end can talk to it, but not use a server. So, is there anything out there that can do that? And we already knew the answer to that. Before we do that, so this project, it had complexity in that we did all this assessment. So if you see this brown to green shaded stuff, there's 17 other layers that are 30-meter resolution that cover the whole coastal United States that are meant to assess fish and wildlife and also coastal resilience. So 30-meter resolution raster data, how are we going to store that? How are we going to access that, and how are we going to have this front end talk to a back end that has that much data, right? And we don't want servers, so this starts getting pretty difficult. The thing is, the reason to do this, and the reason we need to do that, is the problem that the folks were having is they get, National Fish and Wildlife gets $40 million of funds to do restoration projects. So they have to score those projects, so we have to build a tool that helps them look at projects and compare them, right, based on these assessments. Data layers. Is that making sense so far? I'm trying not to get too complex because otherwise I'll just confuse you. So our solution to that was, let's do ad hoc zonal stats. Basically that means someone can upload a shapefile, someone can draw a shape on a map, and it goes to some kind of backend, hopefully not a server, and spits back zonal stats. So this is getting kind of complex, right? It's getting harder to understand how maybe we can do this. So our solution, we were able to eliminating the server, right, and getting rid of that task is, sorry, I got mixed up on that. We still need a way to access as we had a server, right? And the way to do that is Amazon's Lambda, at least for us. So if anyone familiar with Lambda? A few people. So Lambda is basically this idea is you write code, you push that code to Lambda, and it sits on Lambda and waits for a request. And when a request comes to Lambda, this Lambda function sitting on Amazon, it runs it and gives you back results, right? This is exactly what a server does when you have a server. But the cool thing is you don't need a server to do that. Amazon takes care of it all because all you're doing is publishing the code, the function. So in this case, we used Rastero, right? And that's how we're compiling it. So we use Python. Lambda can use Python, Node, or maybe that's it. I think that's it, the two things that it uses. So Python, you can bundle anything you want into it. In this case, we just did Rastero with GDAL, which allows it to do it. Now, for the interesting part, and this is where the magic really happens, is Amazon, along with Lambda, you have to have something that replicates what normally you'd have a server, which what we call an API. So the API is what does the translation between the front end and the back end. So really nice tool, Amazon, it just has a template. You just point to your Lambda function and you tell it what you want the API to look like, and it basically now has an API. So we have an API, we have a function that does zonal stats, and we have no servers. So how this really works is you write some code in GitHub, right? Docker, anyone familiar with Docker? A few people. So Docker is another tool that you can use that basically creates an image of what a server should look like, and you can run it on your local machine. And basically there's a Docker image of Amazon's Lambda server. So that runs actually Amazon Linux. And what you can do is you can write your function there locally. You can see how it works. And when you're done, you can push all of that up to Lambda. Sounds really simple, right? Because it really is. We have another problem, right? I talked about 17 layers. So we have 17 raster layers, 30-meter resolution. They cover the whole United States coast. That's a lot of data. Typically, you would have to upload that to another server, right? And then something like GeoServer or Map Server or maybe ArcGIS Online. Even then, you're starting to pay for a whole lot of storage. So what we did is we just cached the tiles and put them on S3. So S3 is a object storage that you can use on Amazon. And you can also reveal that as a web page. So if we cache the tiles in a tile scheme, and you know the typical tile cache schemes, if you're familiar with that, it then acts like a web page. So as far as the front end's concerned, it is a server. It doesn't know that it's not a server. It just follows that same cache. And I'll show you examples of that in a second. And hopefully, so just real quick, you can see this URL up here. This is the important bit, is from like right here. That's the tile scheme, so you can see one tile. So there's millions of these at different zoom levels. That's how it works. It's like the same slippy map that everyone sees. When we do zonal stats, this is just one point, so this would be like the typical GIS identify. This is what it returns, so this is the API interface. This is what the front end is talking to when it does its work. And, oh, it didn't come up the way I was hoping. And this is the app, so you could do something, and it was supposed to come up, so. I won't fumble through the demo now, but basically that app would have done the same thing. It would have come up and shown you information that we did with the API. So this is the most amazing part to me. One of the things we wanted to do is we wanted to reduce the cost to ourselves and to the people that we do work with. In the old format where we would have a server, we'd have our front end, and we have all these data layers and multiple ways of deploying the data. The cost was running around $100 to $150 a month on Amazon fees. If you add in then when we'd have to go in and troubleshoot anything that was happening or doing patches, you're talking another 4 hours a month over a year, right? It might not all happen in 1 month, but it's happening over that whole year. That starts getting the cost into the thousands of dollars for maintenance for anything. And that's probably true for anybody that builds any kind of tool that they're hosting and building for people. But if you look down here in the bottom, here's the cost of using Lambda and S3 with the same type of application. It starts dropping down to $10 to $15 a month. This is because when you use Lambda, you're only paying for every time that function runs, and that's it. The storage on S3 for all those tiles is incredibly cheap, right? So you're taking advantage of all these very cheap ways to deploy stuff, and then you can deploy the actual app itself onto S3 because it's just a web page. It's just HTML and JavaScript. So now we're at $10 to $15 a month. We have no servers. We don't have to be sysadmins. We eliminate that maintenance cost altogether, and it's just code. Sounds easy peasy, right? And everyone now should be able to go and do that, like today, right? I mean, Amazon only has, what, 30 or 40,000 different options, so it should be really easy to find it. But that's all I have, so questions? So I'll try to go quick so we could go like right to lunch.
I got just curiosity. Where's the client or the application itself?
Yeah, so we have our dev site now. We just use GitHub Pages, eliminating the server. And when we go to production with it, it's going to be S3. So again, we'll just go to S3. We'll put all the code that's compiled there and make it a web page.
Know what your usage stats are, but with Lambda, there could be some slow startup time when the server initially spins up. Have you noticed any major issues around that if it's been stale?
Definitely. So what will happen is, so the question was that the way Lambda works is the first time you call the function, it actually starts a server in the back end. And by the way, it also handles load balancing. So like if you want to get complex sysadmin stuff, trying to create load balanced servers, that auto scale is really difficult. So, but it handles all that for you. So the question was, do you see staleness because you have to wait for this server to start? You definitely see it. So when you're doing zonal stats of large areas where it's taking, you know, for 17 layers, it's taking 1 second, 2 seconds, but that initial one might take 3 or 4 seconds. So we've used other methods in our app itself to kind of hide that and sometimes, and that's the way we kind of handled it. So a lot of times when you're using this particular app, we're taking it and we're caching it basically in like local storage. So that way it's not constantly sending calls to Lambda also, because that's something you don't want to do. The more you call Lambda, the more you're going to pay, so you have to figure out ways to kind of catch it. So that's how we dealt with it, but it's definitely an issue. So if you know, kind of like when you're building load balanced servers, a trick is to kind of pre-load servers if you know there's going to be heavy load. So that'd be a way to do it. Yep.
How long has Amazon offered this?
They've had it for about a year, and is it sustainable? Definitely yes, because on apps like what we build or local governments build, the usage rates are not very high, like relative something that's much bigger. But they're making tremendous money off it, right? Because so the actual, what they charge you like per, they call it CPU second or whatever term they made up to confuse us to try to make money and hide that they're charging us. It's actually way more expensive than running a server 24/7. But for things that we typically build, like a lot of people here, they're never going to reach that cost, break cost even, right? So you'll never make enough calls to equal 24/7, and plus it's handling all that load balancing. It's just cost effective for some groups, and maybe it's not for others, right? So that's a decision you have to make. If you're going to be getting millions of requests, it might become way more expensive to use Lambda, and that's if you don't want to deal with all the DevOps stuff. Does that answer? Yes.
So you've got your tiles already cached on S3.
Yep.
You've got your application code sitting on Lambda. Where does all the raster data library and number crunching on those tiles?
So the tiles are also kept on S3, so I failed to mention that.
Yeah.
So the question was, where do you store all the raster data? And
where do you store all of it? Where does the actual raster libraries? Is it not handled with a database?
no, there's no database. So we had two questions. Where is the raster data that you're doing the zonal stats actually stored, and where do you do the number crunching? So the raster data for the zonal stats is actually stored on S3 because that's incredibly cheap. The Lambda function actually is what does it. So part of doing a Lambda function is you create your code and you create a zip file of your code. And when you deploy that zip file to Lambda, it unpacks it and installs all the stuff with it. And that's why you use Docker.
Every time you
Yeah, basically redoes a whole image, but you don't have to worry about all that complexity. All you have to do is write the code, and I would definitely recommend doing it in the Docker image that replicates Amazon's system, because then you'll know it works, and you'll just push it up. It takes care of all that.
So final output raster data set, is that cached down on the client? Or
Yeah, there's no final output. So what happens is it just the API, the Lambda function runs and gives me back a JSON data of the results.
Okay. So you don't get any final raster data from it?
Nope. We could do that too, but it would we would probably have to do something like S3 to do that. But we haven't had a need to. Yeah, we got a question on how
long is your user community? How much service you use?
That's a great question. We haven't released this yet, so the people who use it is like 4 or 5 of us, but that'll be a great test. So as soon as we release it, I'm going to be really interested in how the performance changes. So my assumption is based on the fact that it's taking care of the load balancing, that it'll work just like it is when I'm using it.
So Amazon, in this case, do they charge you for using it?
They charge you, I'm not going to even try to explain it because we don't have enough time to explain how they charge it, but they call it CPU seconds. It's not actually seconds, it's seconds of CPU based on memory and blah, whatever, this big long paragraph written in a language, I think, to confuse you on purpose, right? But they charge you, yeah, they charge you per call is the way to think about it. And packets of calls, so it's like 100,000 API calls is like 3 or 4 cents per CPU second. I think it's something in that range.
So what other libraries were needed just for the code, like your Lambda function? Docker is basically packaging everything you need to deploy on Lambda. So what other, I guess, third-party libraries what were you actually deploying? Yeah, so the question was about third-party libraries. The only third-party library we used was Rastero, and that actually includes GDAL, so that was it. Okay. And so when Docker's packaging this, it kind of knows what it already needs. When in your Python function, it's like import Rastero or whatever. Yep. Yeah, you do that on the Docker image, and then in code, and then you zip it and send it up. Yep.
On S3, you said that you have that roster images. Would that be a practical source for vector data?
It could be. We experimented with a little bit, but it was going to take too much time to figure out. So when we do vector data, we put it in ArcGIS Online because the API is awesome. But that API doesn't handle raster data the same way, right? We would need spatial analysts, and that drives the cost like way beyond what we wanted. So most of the organizations we work have ways of dealing with vector data, so we weren't going to try to reinvent that. But you certainly could do something, if you wanted to, very easily put vector data out there and replicate the REST API, which is an open source type format, right? It's a standard format that other people can do, if that makes sense. If you wanted to, you could replicate that with that gateway API. Certainly, I think it would work just as fast. It works really fast in this. I was actually surprised with how fast S3 was able to do the zonal stats, because that was something I was afraid of, because it's like not actually a disk, right? So I was afraid with how long that was going to take. But it seems to be working fine. Is there a question over here? Anything else? Cool, thank you.